Welcome to the deep dive. We're jumping straight into a really fascinating part of AI today, AI agents. And we're not talking simple chatbots here. Think systems that can actually, plan things out, make decisions, adapt.
And act autonomously. Yeah, it's a huge leap.
It really is. And there are projects like Hugging Face's smolagents, making it easier to build these specialized and, importantly, secure code agents.
Yeah.
Seems much more accessible now.
Absolutely. The progress has been pretty stunning, actually. Not long ago, models were, well, much more static. Now we've got these things that can actively pursue goals.
Right. So in this deep dive, that's what we want to explore. We'll look at sort of the journey of these agents.
Yeah.
Then we get practical, build a basic one with smolagents.
Okay.
And crucially, look at safety, how to make sure they execute code without, breaking things.
A very important point.
Yeah, and monitoring them, seeing how they perform, and even pushing further to build agents that can do deep research.
Yeah.
So let's get into it.
Sounds good. And maybe it helps to think about an agency continuum, like different levels.
Okay, yeah.
So level 0, that's your basic chatbot. Stateless, doesn't remember the last thing you said.
Right.
Then you move up. Levels with memory, reasoning, using tools, all the way up to maybe level 3, which is recursive self-improvement. Agents setting their own goals. That's the frontier.
Wow. And this isn't just theory, right? You mentioned autonomous driving as maybe an analogy.
Exactly. Think driver assist, that's maybe level 1 agency. The system helps, but you're in charge. Full self-driving, that's aiming for something closer to level 3, much more autonomy. It shows the progression.
Okay, so there was this idea you mentioned earlier, this S-curve of effectiveness. It wasn't just straight improvement as we added more features.
No, not at all. That's a really key insight.
Yeah.
Early on, just throwing more agency, like more tools or planning ability didn't always help. Sometimes it actually made performance worse.
Huh. Like too many options.
Kind of. Like a Swiss Army knife with no instructions. Lots of potential, but maybe just cut yourself. But the big breakthroughs recently in prompting, better tools, much smarter memory, that's pushed us onto the steep part of the curve. Now these agents are genuinely becoming effective at complex stuff. Understanding that curve helps manage expectations, Sometimes progress seems slow, then suddenly jumps forward.
Gotcha. And just to be clear, when we say code agents, we mean something specific, right? Not just fancy Q&A.
Precisely. Code agents are built to achieve goals by writing and running code. Their main output isn't just text, it's working code.
So they create solutions using code, like an automated developer almost.
In a way, yes. Less about finding an answer, more about building it.
Cool. So how easy is it to actually, build one? Our sources showed a smolagents example that looked surprisingly simple.
It really is quite accessible to get started. That's one of the main goals of smolagents, I think. Just a few lines of Python.
Okay, let's walk through that code snippet. It was from smolagents import agent, then agent.
Right. So first you import the agent class. Simple enough.
Then you create one. Agent. Agent says you are a helpful coding agent. That bit seems important.
It's crucial. The system prompt is like the agent's core directive. Its personality, its goal. Here, we're telling it, be a coder, solve problems with Python.
Okay, sets the stage. Then response, agent.run. Write a function.
Yeah, the run method is where you give it this specific job. Write a factorial function in this case. The agent takes that, combines it with its system prompt identity, and uses the underlying LLM to generate the code.
And boom, out pops the Python code for factorial.
Exactly. Like this .python, if n equals 0, if n equals 0, 0, then os, nl else, return n factorial n1.
It works. It's remarkably straightforward to get that far. But letting an AI just run in code it wrote, that immediately sounds risky, like potentially very risky. Opens a whole can of worms, doesn't it?
You've absolutely hit on the critical challenge. Letting agents execute arbitrary code is, well, inherently dangerous. It could try undefined commands, import nasty libraries, get stuck in loops.
Right. So we need safeguards. How do we build safe agents? The sources mentioned a few strategies. Capturing exceptions first.
Yeah, that's basic good practice, just like a normal programming. Wrap the code execution in a try that except block.
Okay.
So if the agent's code throws an error, your whole system doesn't just crash and burn. You catch it gracefully.
Makes sense. Like a safety net. What about filtering commands it doesn't know or shouldn't know?
Right. Restricting the execution environment. When you run the code using something like exec, you can give it a very limited set of allowed functions, sanitize globals and locals.
Ah, so it's like it only has access to the specific tools you hand it.
Yeah.
Nothing else from the wider system.
Exactly. Blinders on, in a way. Which leads to the next point. Preventing dangerous imports.
Like OS or subprocess.
Precisely those. If an agent can import us, it could potentially start deleting files, running system commands, really bad stuff.
Yikes, okay.
So you absolutely need to scan the code it generates for those forbidden keywords, either block them outright or only allow a very specific whitelist of safe imports.
Definitely don't want that door open. What about infinite loops, the bane of every programmer?
Oh yeah, huge resource drain risk. If the agent writes code that never stops, it could grind everything to a halt.
So timeouts.
That's the main solution. Run the agent's code in a separate thread, or even better, a separate process, and set a strict time limit. If it runs longer than, say, 2 seconds,
You kill it.
you terminate it. Prevents it from hogging resources forever.
Sensible. And for really critical stuff, sandbox execution was mentioned, using multiprocessing or Docker.
Yeah, that's about stronger isolation. Running it in a separate process using multiprocessing is much safer than just a thread.
Okay.
And for maximum security, especially if you're dealing with potentially untrusted code, Docker containers are the way to go. It's like a completely sealed room for the code to run in. Minimal access to the host system.
Like a quarantine zone?
Exactly.
Yeah.
The sources even had that multiprocessing example, right?
Yeah, let me find it. Here, python.import multiprocessing, def safeexec, code timeout 2, hashtag.target function with try except, .def safex code timeout 2, .p multiprocessing.target.def safeexec code timeout 2, .pt timeout 2, .p join timeout, .p join timeout 2, .ps terminate, .if piece alive, hashtag print messages.
See? It defines that safeexec function. It spins up a separate process, runs the code with limited built-ins like print and range, catches exceptions.
And crucially, has that p join timeout and the termination line.
Exactly. A practical way to mitigate those risks we talked about.
Okay, great. So we've built a basic agent. We've thought hard about making it safe. But how do we actually know if it's any good? Is it working? Which brings us to monitoring and evaluation.
So important. Building it is step one. Making
Right.
sure it works and works reliably. That's an ongoing process. You need to track what it's doing.
It's iterative, right? Build, monitor, refine.
Totally. And the source is mentioned Phoenix.hotel for this.
Yeah, what is that exactly? Open telemetry.
Right. Phoenix.hotel is built on open telemetry standards. It's specifically designed for monitoring LLM applications, like our agents. It helps you collect and visualize all sorts of data about the agent's runs.
What kind of data should we be looking at?
Key things are like latency, how fast is it? Success versus error rates, is it actually solving the tasks?
Okay.
Token usage, how much is it costing computationally? And really importantly, user feedback, if applicable. Are people finding it useful?
Gives you the whole picture. And integrating it looked pretty simple, too.
Surprisingly simple, yeah. It was something like .python from phoenix.trace, import inittracing, service name code agent, #.agentcode.agesh.run, write a quick sort algorithm.
So just initialize the tracing with a name.
And then every agent.run call or other traced actions get logged automatically.
What does that let you do with the data?
You can then go into the Phoenix UI or whatever backend you're using and see detailed traces, see exactly where errors happen, how long each step took, resource usage.
So you can pinpoint bottlenecks or figure out why it failed on a specific task.
Precisely. It lets you diagnose problems and then fine-tune the agent, maybe tweak the prompt, give it different tools, adjust the logic to make it better.
Okay, that closes the loop nicely. Build, secure, monitor, improve. But then the sources went a step further. Deep research agents. Sounds powerful.
It really is an expansion of scope. Because generating code is great, but often you need info the agent doesn't have internally. You need live, up-to-date information.
From the web?
From the web, from databases, from APIs. Agents need to be able to go get information sometimes. That's where research capabilities come in.
And the tool mentioned for web browsing was Tavily Browser.
Yes, Tavily is a search API designed specifically for LLMs and agents. It allows the agent to perform web searches, get back summarized results, and use that information. It's a form of RAG retrieval augmented generation.
Retrieval augmented generation. Okay, so it retrieves info, then generates based on it. How does that plug into smolagents?
Again, quite elegantly, the example was like this. Python from smolagents import agent. From import agent, Mitchell. Tavily Browser. Tavily Browser on Tavily Browser. Tavily Browser. Tavily Browser.
Agent. You are a deep research coding agent. #add the browser here.
#agent.run.
You just create the browser object and pass it in the tools list when creating the agent.
Exactly. You're telling the agent, okay, you now have this web browsing tool in your toolkit.
And the example query was pretty ambitious. Find the latest algorithm for fast matrix multiplication and implement it.
Right. So the agent wouldn't just rely on its training data, which might be outdated.
I could actually go search. Find maybe a new paper on AutoCAD.
Pull out the key details of the algorithm, understand it, and then write the Python code to implement that specific cutting-edge method.
Wow, that's a different level. It combines the coding with active information seeking.
A very powerful combination. Reasoning, coding, plus access to current world knowledge opens up a lot of possibilities.
It really is amazing to see that progression. Basic chatbots seem miles away now. We've got agents reasoning, coding, researching, maybe even improving themselves down the line.
We really are seeing a convergence of these capabilities. It's creating some incredibly powerful tools.
And the accessibility is key. Frameworks like smolagents, tools like Tavily for search, Phoenix.hotel for monitoring, they're putting this power into more developers' hands.
Absolutely. It's democratizing agent development in a way. Not just huge labs, but smaller teams, even individuals, can start building sophisticated agents.
So wrapping up this deep dive, it really does make you think. The sources ended with that question, what will you build?
Yeah.
It feels like the potential applications are just starting to be explored.
For sure. Agents that can reason, code, research autonomously. It's exciting to imagine how you could apply that to solve problems we face today or create entirely new things.
Well, thanks for joining us for this deep dive. It's been really illuminating exploring these AI agents. Hope it gave you listening some things to chew on, maybe even spark some ideas. Until our next deep dive.